Electrics and water are not generally considered compatible, but this wet day in November is the exception. A dry workshop and a Panther Grand Sports in need of a wiring loom awaits us inside. So let's get weaving. A little simple spanner work first, the fumbled attachment of a headlight shell. My fingers not yet warmed up. And a rubber trim is needed on the side panel below the tank. The parrot beak rear outer mudguard must come off for access to the main connection points below the saddle, and the tank for that cable along the top tube. The mudguards are due a coat of underseal, so I remove the front and do all three. The rear light attaches to this parrot beak outer guard, but we can estimate its position applying the golden rule of cable making: cut long and shorten if required. Experience shows that cutting short can result in minus numbers. As one whose arithmetic is still at the "you have 3 oranges and I take 1 away, how many are left" stage, I'm stalled at the teacher's next, demanding 4 of my 3. Minus numbers don't really work, do they? Not for oranges or cable making. Basic tools are a plank, a felt marker pen, screws and driver, and a measuring tape, crimping pliers, side cutters, wire stripper, soldering iron and heat gun. I hope you're taking notes. Basic materials are coloured wire, connectors, solder and heat shrink tubing. Measure the distance between headlight and tail lights. Allow an extra foot for deflections, 300 millimeters on post-metrication motorcycles, and drive 2 screws into the board that distance apart. Place a third screw at a roughly central point corresponding to the nerve centre below the saddle. Wires meet there from all the important positions, each of which needs a further screw. Aside from the headlight, ammeter and dip and horn switches at the front and the rear and brake lights at the back, these additional positions are the diode pack rectifier, the brake switch, Villiers engine's 6-way plug, the horn, a pair of ignition coils, and in the right-hand panel a battery. Some wires will take a roundabout route to their destination, so allow for this as you add the screws. Distances between these points should be straight lines to make wrapping simpler, and splaying them out leaves room to wrap the cables once they are laid in place. Double check against the wiring diagram that you haven't forgotten anything. We're using a pre-wired dip horn switch, so connections for that will terminate in the headlight. Working methodically, take clues from the diagram and begin running wires. Modern cable has thinner, more flexible insulation than the original and comes in a good colour range. I'm matching ours to the Villiers wiring diagram for easy tracing when we come to make connections. The 16 amp capacity of this is good enough for anything that we are likely to ask of the system, and we'll fit a fuse holder. Note that it's a non-standard item on the diagram. The cheapskates. In the event of a disastrous short circuit, our 10 amp fuse will blow long before the wiring melts. Can't ask for more than that. Just don't be tempted to replace a constantly blowing fuse with a nail. No names, no pack drill, Jeff. Where colours aren't marked for optional inverted commas equipment like a stop lamp and horn, this was laid out in the late 1950s, remember, we'll choose a colour unused elsewhere and note it in the book. Be generous with the wire, allowing 6 to 8 inches when you tie off ends at the screws. Stretching taut will make it easier to wrap than a bundle of loose strands flopping about. We begin with a long end-to-end run, connecting headlight switch to tail light. A second, in brown, is for the earth return. Manufacturers making hundreds of looms made worthwhile savings by using the frame as earth, but this method provides too many opportunities for breaks in continuity at bolted joints and even possibly ball bearing tracks. Running separate earth wires is a guarantee of more reliable electrics. The brake light wire is in 2 sections, one from headlight to switch, looping around that central screw, and a second run links switch to brake light, again hooking over the central point. No matter how many times you check and double check, there's still a chance that something will be forgotten. So run a spare wire from headlight to that central point in an unused colour and mark it with tape. It might just save your day. When you're sure that all the wires are in place, get wrapping. This plain polythene tape has some stretch for a snug finish and can be stripped off in the event of a blunder, so it works for me. After an initial couple of turns to secure the end, I wrap with an overlap of half a turn, keeping it flat for a double layer all along the cable. First wrapping run is from headlight to that central junction point, secured at journey's end with a small piece of electrical tape. These wires run to the Villiers engine connection's 6-pin plug. I unwrap the ends from their screw, gather them together, and beginning at the junction, wrap along towards the outer end. Working in that direction avoids the possibility of ending with a bunch of slack wire loops at that central junction. Brake switch wires, and those for the coils and diode pack, are worked the same way, inside to out, until all we have left is that long run along the rear mudguard to the rear light. Beginning at the end of your first run from the headlight, wrap across the central junction, collecting the ends of previous wraps until you pick up the rear light wires, and continue wrapping to the end. Secure with a piece of tape, remove the loom from the board, and finish all outer ends with heat shrink tubing. And that just about wraps it up. Next phase is to feed it into the frame with the central bundle stuffed under the saddle. The rear lighting wire run alongside the mudguard, and the switch run to the headlight secured with cable ties. The loom needs protection wherever it passes through steel pressings, notably the headlight shell, the side panels to battery and brake light switch, and the rear outer mudguard. A cross cut in the big headlight grommet takes the long frame run and the lead from dip switch and horn button. Hook them below the spring steel clip, ready for connection. Shock protection for the 6-volt absorbed glass mat battery is cut to fit the enclosure from a block of foam plastic, suitably hollowed out. Another block, glued to the lid, is slit to carry spare fuses. We used hole saws in the old days, but step drills are unparalleled for cutting clean holes in thin sheet. The size checked with calipers against a grommet, this one is run in as far as the 12mm or half-inch size.
Okay, on the way in a tick, thank you.
Fit grommets and route the wires. With ends twisted and tinned, I crimp on spade terminals for a trial connection of the brake switch by way of encouragement. An ohm meter connected at headlight input and rear light position gives us our first hint of success. Rear light leads need to be secured along the inner guard before we can refit the parrot beak enclosure and run them through a grommet to the number plate and its light. 3 holes along the rolled edge take pop riveted nylon cable clips. When we start to make connections and test the main loom, we'll need the battery in place. So I solder and heat shrink a fuse holder to the positive input and crimp on battery connection eyes for that and the earth wire. The Panther Grand Sport's headlight switch has seen 20 or 30 years of use and will benefit from a makeover before it's put back into service. These solid post-war Lucas switch units make contact via a spring-loaded roller rather than the cheap and frequently nasty wiping contacts. And they're simple to dismantle. Remove the circlip, press the roller against its spring and slide free the spindle assembly. A degrease with brake cleaner is followed by a brighten up with wire wool and a smear of Vaseline on the spindle before reassembly and fitting into the headlight. Plug caps don't last forever, and we'll fit new ones as a matter of course. If you suspect that yours are responsible for an occasional misfire, run the engine up at night and they'll give themselves away. The Villiers 3T engine's original 6-pin plug can only be described as knackered, though an epoxy repair has kept it going well beyond its allotted span. We've a new plug body standing by, and it's just a matter of rescuing the pins, giving them a clean and soldering them to the new loom. A brighten up with wire wool, degrease, a puff with the air gun and a dip in Baker's fluid flux makes them ready for tinning. The 6 coloured wires, stripped for action, are also solder tinned before we unite them. A tug test shows the joints are secure before they're set to length in their relevant positions in the hard rubber plug. I secure the pins with a spot of superglue. I'm testing a sample of mouldable, self-curing plastic to support the emerging wires, but in the end there's not really quite enough of it. We'll come back to that. The system will be testable, and I'm keen to see some results before we pack in for the night. Since the Villiers twins were sold as self-sufficient units and need no external power to run, our coil packs only require connection to the engine plug, with ignition coils below the saddle already connected to earth and the spark plugs. We need only to feed from the Villiers generator's primary coils and contact breakers to get them sparking. I strip the coil wires and the feeds from the Villiers plug, tin with solder, add crimped connectors and plug in. And with the right hand plug removed, I douse the lights to turn the engine over by hand on the kickstart and see the spark which will one day give us a running engine.